This is the second episode where I've had some less than stellar audio, so I wanted to just first call out our wonderful editor, Matthew, who's been working with some garbage I've been handing him, and also to pour one out for my AT2020 USB. It was a 13-year microphone, and it is now, unfortunately, given up the ghost. That being said, this episode with Bitluni turned out great. Content continues to be king, and future episodes of the Amp Hour will be with a shiny new microphone. So thanks for listening. This is the Amp Hour podcast. Released July 11th, 2024. Episode 673. Lifelong Learning with Bitluni. Welcome to the Amp Hour. I'm Chris Gamble of Contextual Electronics.
I am Matthias, also known as Bitluni on YouTube.
Hey, what's up, Matthias? Welcome. And sometimes Looney you said as well, so maybe we'll go by Looney.
Yeah, that's my short. Yeah, thanks for having me.
I like it. Hey, my pleasure to have you here. We've been talking about your stuff a bunch. We just had Matt Venn on a couple shows ago talking about silicon, so we'll definitely be talking about your entrance into that market. But before we do that, I mean, you've been making electronics on YouTube for a while now. So what do you like building?
Yeah, it's been now 11 years on YouTube. Yeah, it's a lot. I mean, my background is not in electronics, really. I'm a coder, rather. And that started as a hobby. While I think one of the first projects was MIDI pedals and music instruments, synthesizers. That were the first projects that I documented on YouTube, and very poor quality. You can still rewatch them. I didn't take them off. And then it grew like with Arduino and ESPs at some point. And then some of the more popular projects were like the LED walls, the ping pong LED walls, which are very basic projects, but reaching like the crowd out there and people who do it as a hobby and looks nice always.
Yeah. No, I think that's the kind of stuff that when people think about projects they want to build, it's stuff like that, right? It's like it's showing people the stuff that they see it and it's maybe accessible, but then there's a technical challenge to it, and it's also something that they're like, I want that on my wall, right? That's like a great combination because you're showing people how to do it, and then you're also kind of inspiring them with these early projects. I'm always surprised that the first projects are often tough ones to find for beginners, and not beginners, even just anyone who's kind of diving into the world of electronics. It's like, what do I build first?
Yeah, usually it's something that's more presentable, or I had like always, the thing was where I reach people in the beginning. Now it changed a lot, but was because I was a beginner myself. Mm-hmm. And I was like this Dunning-Kruger effect. I was convinced, now I'm a crack because I made a PCB or something. But I was documenting all the process along the way, and I didn't know the specific terms or the language of electronics. I barely knew Ohm's law or anything. And that was like maybe the language that most of the people who were interested in those topics were speaking and understanding, and that's why they kept following. And I think that changed a lot. I'm still in this Dunning-Kruger bubble where I think I can make ASICs at the end. Or
I mean, you are making ASICs, just so we're clear here. I mean, but I think you're right. The mindset of like I can do it. That's a big bold jump, right? Where it's
it's
you
bold.
Can do it, but.
It's bold to it works somehow, and now I present it to the world as here I am. I'm the crack in
right.
electronics.
Of course I did this. Look what I have brought.
the rule of YouTube makers, it has to run once for the camera. No, it's
movie magic.
It's a joke, but now I moved on to a little bit more complicated projects. Also, like every topic that's quite interesting to me, I take on that and try to do a little bit of research. I don't know if you have seen the video about like phased arrays. That's
the
like
DIY sonar scanner one.
Yeah, the sonar scanner.
Yeah,
that was something was more in the educational realm, let's say, where I presented how waves propagate visually. And many people like that video, even though it's not like the video with the most reach. But yeah, some people like that one. And actually, that's one of the projects I want to continue. I started with FPGAs after that to be able to tickle out of more of that sonar scanner stuff. I don't know if we can maybe
yeah.
talk.
So that was like So that was like you were processing. You were like basically like imaging the world. I think I remember seeing there was stuff. I remember watching it and thinking like it was kind of like Daredevil, the Netflix version of Daredevil kind of thing, where you were actually visualizing the world by doing sonar mounts, right?
Yeah. That was the core of the project. Was basically ultrasonic scanners, but as an array, and then you can basically reconstruct where the echoes in space, in 2D space. You can make it, you can do it in 3D space as well, but that was only like a 2D, like 1D array, and that was visualizing basically the space in front of you. And there is like a story to this project specifically.
Yeah.
So my goal for that was to you probably know the movie Aliens.
I never watched all of it, but I know many of the high points.
The second one.
The second one, yeah.
James Cameron. Yeah, they have like sonar scanners there. Like they visualize like the aliens, and it has like the specific sound. And now, yeah, I was always fascinated. It was a fake on the movie. Actually, if you watch, I'm a film fan, and if you watch like the making of, it was like the CRT is like way too long. There is like a color CRT, and you look at from the top, so you can actually, you don't see that it's sticking out of this whole contraption just to show the visuals. So it's not real there, but I wanted to make it real even with those CRT screens. So that was another thing of mine, doing graphics on CRTs, generating video signals and so on.
See, that's great too, because it's going to be like, some younger, YouTuber is going to watch your stuff and do that, and it'll be like art inspiring science, inspiring art, inspiring science, and then you just get these like leapfrog effects of just, how it goes through the ages.
And fun fact is, I never finished that, like the actual scanner right now. I have a version that is not like, it's not film, but I have like FPGA version that I started to do on stream, which is a little bit faster, like because you can decode in parallel and stuff. And now the Alien movie Romulus is coming out in 6 weeks, roundabout, and they you can hear in the trailer already that they use those scanners again. So
really?
That's
okay.
That's a hot topic, and I think.
So wait, is that like the same? That's the same universe, but like a new version? Is it like they're kind of continuing the saga?
I think it's like a prequel, or there's like, okay. I mean, the whole story, Prometheus and so on, it started before the Alien movies later, and it's something in the middle between the prequels and the movies from the 79 and 82, no, 82 or 88. Something like that,
right? But same franchise, same like kind of like
yes. And I hope they pick up like in the old style from James Cameron or Ridley Scott.
Mm-hmm. Yeah, I get a little frightened of those kind of movies. I'm a bit of a wimp, so.
Oh really?
Yeah, I don't know why. I think also when it like came out, it was like it came out a little bit before I was born, and then it was through my whole childhood. I was like not allowed to watch them, and then by the time I did, I just wasn't. Yeah, so. Maybe I should do it now. You know what? I'll watch a video. I'll go watch the scanner thing.
Oh wow, yeah. You can watch. I mean, the new one. I hope it's good.
Yeah.
You should check it out. At least I will try to finish that project. Most of the projects are never finished.
Yeah.
I will try to finish it like somewhere on time to be in this trend bubble.
Right. Well, what you really got to do is try and get the movie to pay you to do the content. That's what you really need.
Oh,
call the studio. Yeah.
Usually that never YouTube rarely pays. I don't know.
Right,
you have to be Mr. Beast to be.
That's right. Exactly. Yeah. It's a winner take all. One thing I like about looking through all of your video kind of just thumbnails and just the things you're doing there too. One thing that I think really kind of pops out to me, especially with the phased array, is beginners. Just me as a beginner, right? I always looked at the ultrasonic sensors. It's like these are the ones that look like little cans that have like the screen on over them. I was looking at them. I'm like, oh, there's so much I could do with them. And then it's, basically I just run the Arduino sketch where it's just like my hand's getting closer and closer, and I'm doing just like the distance, and that's interesting, but not that interesting. And so like the fact that you're taking this stuff and then extending it into the realm of interesting and almost past, like those ultrasonic sensors are not meant for that space, but they can be used in that space. And then you're kind of testing the limits of where they are and then doing a lot of software and other kind of interesting things around it. That's really powerful, I feel like, because it shows all the things people could be doing with them.
Yeah. What I was, when I was doing this project, it took me like 3 months to do everything and record. And I think that video is all right, popular. I think 600,000 views or something, maybe more now. Yeah. But it barely paid for my upkeep, let's say so. And it was a lot of work.
Right.
And
yeah.
Okay, that's a little bit of YouTube meta. But during that work, I learned, like, this is the part of this lifelong learning or self-taught things, that the technology of the arrays, the phased arrays, where you have like beamforming is the keyword here, opened up to me all the parallels of the technology. I mean, that's not working only in sound, it's also in electromagnetical space, light, and so on. Yeah. It works in all the realms similarly. The funny thing is that I didn't think a lot about that when I used those distance sensors. I actually sorted off the cans of this distance sensors to like start doing that project before I ordered parts and so on. That ultrasound scanners or medical ultrasound scanners, basically, they work the same way. It's identical. Yeah. And I worked in that area for 5 years as a coder, like
really?
Making 3D visuals for medical treatment and ultrasonic and also CT and stuff like that. And all that stuff works the same way, but a little bit smaller, microscopic, crystals and so on.
Better, fancier sensors, right? I mean, like more tuned, higher quality, better power supplies. It really, like you're saying, the same thing applies. It's just then why is the cost so much higher? It's because of all the other engineering that goes into it, right? I mean, like all the precision you require.
And the fancy thing is about that, like, I mean, the topic about phased arrays, they have been around for I don't know how long, like as long as radio is around. Because you have like the array antennas and so on for basically radars, of course, like military stuff.
Sure.
So that's like analog stuff. And it's always amazing to see what is already possible, even though if you have no computation power at all.
Oh, yeah.
I mean, that's all analog. And then you just process the outcome, the result. And stuff like ultrasonic scanners or CT scanners, they work basically the same. They have been around from the 80s. Roundabout, I don't know, maybe earlier. I don't know for sure.
Yeah, I'm not sure.
So that's always like mind-blowing to me to see. We had like C64s back then or computers like that.
Yeah, right.
And then you are able to visualize the internals of a human body or something, or see airplanes on the radar.
I think as the costs come down too, I mean, some of it is just true unit economics too, right? So you think about the earliest CT scanners, it was all this work just to get that one thing working. So of course it's going to be the priciest thing, but then as you start to have standardized components, as the industry grows, it feeds back on itself. You have other electronics coming in, compute getting lower, like all of these things get lower. And even to the point where, like, for ultrasonic, so a former guest, Greg Charvat, who was on the show a whole bunch back in the day, he worked on one that's literally like a handheld ultrasonic that talks to an iPhone. That's called Butterfly Networks. Butterfly Networks is the Bitcoin miner. There's a Butterfly whatever. And it's literally like a handheld ultrasonic, so you could do remote medicine.
Oh, yeah, telemedicine,
yeah, it's amazing. And that's the level it's shrinking down to now. And then it just keeps feeding back on itself. And then it finds new areas like you were talking about. Yeah, it's just technology, man.
Yeah. But it's also amazing how analog tech, humans developed analog tech before digital, even though digital is way simpler. And analog, like the physics, developing all the physics and making it work, CRT TVs. It's crazy. There's like a accelerator beam that's shooting at you and displaying images.
Yeah, right. What we do is we shoot electrons, but then we stop them with phosphorus.
Yeah.
Yeah. And then we're going to put kids in front of this screen so they can watch TV.
And then you use high voltage, like this high voltage beam, and then magnets to deflect it and to draw super fast in the image that's transferred over air. And that's barely, like, that was developed barely after we made a telephone or something.
Yeah, right. Exactly.
Telegraphs.
Well, I mean, yeah, right. And I mean, in this realm of like technological surplus, also like, I feel like cognitive surplus is like a bad term, but it's not really. It's like people who are spending free time exploring, right? I mean, it's your community. It's, the stuff that say you're a lifelong learner as well. One of the things that is limiting at that point is just where we're pointing this technology. Like, so again, looking at all the videos you've made, ESP32 is very common in your projects, and just the amount of compute power that's in there and like things you could point it at, it really comes down to just how much people can dream up and actually point it at. If you think about the surplus, the technological surplus of ESP32 and what you like to point that stuff at, where would you say you like pointing the ESP32 these days? We're going to get into the chip stuff later, but otherwise, right, you kind of have focused on the ESP32 as a platform and as an enabler. Where do you like pointing that stuff? I see like a lot of like visualization and video and things like that, but maybe there's other areas.
So my thing is always like testing the limits of stuff like that. It seems like the microcontrollers are getting so powerful that that's overwhelming. I mean, the possibilities are basically endless. You can run Linux computers basically and do everything on them.
Yeah.
That's the current state of microcontrollers. So where Raspberry Pi started at some point, there is where we end up connecting to with the ESPs right now, or other brands as well. Mm-hmm. Also, the FPGAs, they are so cheap and affordable. The ones that I'm using right now, the GoWin FPGAs, like $20 for the 9K. One is able to run MS-DOS emulator on that with HDMI output. So basically, you have everything what use whole computer from the 90s on this $20 FPGA, and you can
like you said. I mean, like all the things they were doing with that in the digital analog realm as well. So now you've basically all compute held within your hand, right?
So this is like the one thing that I see, and there are almost no limits right now, or the limits, or let's say you have to spend way more time to reach the limits or exhaust the capabilities of one microcontroller right now. But that was one thing that I tried to do with the ESPs back then. We talked about the video generation, like CRT control, and basically the signals, color signals, encoding. That was one of the limits of the ESP32, the first version. It was able to output parallel data that with a R2R resistor ladder DAC. And it had like two built-in DACs that they removed now. So there on the S3, there is no DACs anymore, unfortunately.
Yeah.
But that was good enough to generate basically a video signal with color. And that were limits, because you have to have the right clock and so on. There isn't PLL clock on there. APLL clock, they also removed that one. So you could use APLL clock to output the video signal at the right rate to generate the color video. But it's also possible on the older ones, like Charles Lohr showed, I think on ASP8266, like NTSC generation, and also transmitting from the wire the video.
Yeah, I think Charles is in his own, we're talking about like the excess of technology, and Charles is like, well, there's transistors here, so I can make it do something weird.
Yeah. So he's also one of the geniuses, or he is one genius that also always explores the limits of certain platform.
I agree. Yeah. I would put you both in the same category. Yes.
Yeah, we met also on Hackaday SuperCon twice now. I think twice was it. So we are like-minded, but he's way ahead of me, and that's,
we all gotta have heroes, I look up to
Yeah, actually, before I started my YouTube channel, I think I was subscribed to a few of other channels, like Dave Jones was the common one to watch, but also Charles's videos were my reference how to make PCBs at home. He had like videos early on how to etch PCBs. I used a little different method. Sodium persulfate was mine. He was using like some chlorine.
Cupric probably the
which is
EU versus
like,
US. In the US, we're just like pouring it down the drain. We're like,
but also getting like the sodium persulfate here isn't like straightforward. So
oh, really?
You have to, you don't have to register, but I think you will be tracked or something. If you order that, you have to specify the purpose that you're ordering it for. And then you probably will be tracked or on the screen of the federal investigation, because you can basically build a bomb or something.
Yeah. Enterprising individuals.
PCB etching was once a cool thing, but now really not necessary.
I was going to say like a necessary thing is a better way to say it, right? I mean, like,
it's now you can get boards like within 2 days or something delivered for a few bucks. Why would bother buying like stuff for hundreds of dollars or euros to etch it at home? I made the most popular videos, I think, milling PCBs on like
that's
this
right.
$150
the cheap milling machine.
Almost forgot about that. That is one of the videos that I made. It was the most viewed.
Yeah, but people should watch that video just for the first 10 seconds where Looney puts in a meme, the cat meme.
Yes, true. I should buy a mill. That was the one.
I should buy a mill.
I almost forgot. That's so long ago. Oh, damn.
Deep memes.
Basically. And that is also, I think, a good transition, because when I started doing this 11 years ago, getting PCBs from China, it was possible, I think. It wasn't like as straightforward, or like from Germany as well. It wasn't as straightforward as nowadays or as common. So that went obsolete, and now it's quite common, at least for me, to get some PCB. You can even do PCB art, and we have a lot of capabilities, or assembly, even like super cheap assembly. That's amazing. That's amazing. And you can explore. You have the possibility to fail, because without being like financially catastrophe for you.
Exactly.
If you can imagine, I mean, you wanted to do a project, and then you submit like an assembly, you wait like months. That was once in a time. You wait for months, you pay hundreds of bucks, maybe thousands, and then you discover, like, after you submitted and you're full in production, you discover errors, and then devastating stuff.
Listeners here will understand that he is actually explaining the silicon process currently. This is called foreshadowing.
And that's basically what blew my mind with Tiny Tape Out. That we went from the process of developing PCBs, so making PCBs ourselves. I mean, Jerry Ellsworth also made silicon back then. Herself in her kitchen with
home etching, right? Home etching.
So there are a few people out there who make silicon at home, which is like crazy. What stuff even make a transistor alone is so much.
And they're like, effort. I mixed together like Drano, and I was just thinking about Jerry and Sam, and I think Ben did some of this too. All of them just Ben. Like, they're like, I just bought this stuff off the shelf, and you just reuse this thing, and this is in your kitchen cabinet, but it can be used for this other purpose. It was like, what? First off, what am I using on my countertops? And second off, I gotta lock the cabinets. I got kids now, like it's some dangerous stuff.
Oh, true, Yeah, Ben is also amazing. Every time I see one of his videos, I just put everything aside and sit down and enjoy myself for half an hour.
And these days too, it's like, what am I going to learn about chemistry? I feel like that's like a whole other realm that we're talking about. Ben Krasnow, for people that I'm always get criticized. I'm like, Jerry and Ben and Sam. So we've been talking about Jerry Ellsworth, Sam Zaloof, Ben Krasnow, but Ben has been doing chemical stuff, like chemistry, basically.
Science is the name. He renamed his channel.
That's right. Thank you. Yeah, that's good. Yeah, and that's another area where it just feels like it's very out of reach. But Ben shows that it's like, you do measurements, you read papers, you have some simple equipment, and it's accessible. And it's like, wow, that is that is a leap that I am not personally willing to make, but it is possible, and it's going to enable more people to try stuff. Have you ever dabbled in that realm? I mean, I guess you said you home etching type stuff.
Oh, no, not really. I think the stuff that you need to have like furnace and whatnot and to get the
Mm.
silicon and stuff, I don't know. I think my ADHD wouldn't allow it to finish stuff.
You're right. That's a bake for how long?
I mean, I can imagine myself getting all the stuff, the equipment, and so on, but then it's sitting around. It's also in some corner next to the other projects that I never finished.
Right. Background decoration. Yeah.
Yeah. Yeah,
Right.
so that was basically the segue that the PCBs to the ASIC stuff,
Yeah.
which we see now after 10 years. Like we made those leaps in manufacturing actually
Mhm.
to make it accessible to people, which I wouldn't be able to even imagine that you can make your own silicon at some point. And Tiny Tape Out allowed like with like for $150, it's now I think per run. I think it was cheaper in the beginning because it was really funded by eFabless.
That's right. Yeah, Matt said they upped the price because it was not well calculated
Yeah.
at the beginning, but now it's more realistic with a sustainable business, which is like, okay, sure. We would like
Yeah,
to
and
stick with.
that's cool. I mean, if you can do like what is Tiny Tape thing? That was now Tiny Tape Out 7, I think.
Yeah,
Was the
eight
run
eight is
that's closed?
going. September 6th is closing.
Yeah, it's open now, and if you can make it sustainable on the 8th run, which is it's amazing, it's cool because it takes so long that's one disadvantage right now, that you have to be patient right now. If they can finish it in 10 months, it's all right.
Yep.
But still, like for price that it's priced in the realm of to being a hobby without being a serious business.
Right.
No, you can use it for business, for like developing R&D and stuff like that, to have like some iteration maybe before you try yourself and fund like the whole run for 10K per chip. The whole chip is I think the price. Yeah, as a show like piece to for fundings and so on.
Well, we brought your work up on the show a couple times now. Most recently, the best chip in the world. Let's talk about that. That was
Oh
your.
damn. Yeah.
Since we're
Oh
talking about
no,
the importance of raising funding and doing important R&D, Bitluni,
yeah.
what did you build? What have you run?
Oh damn. Yeah. So actually, that was the meme project. That was the last one for that Tiny Tape Out. That was Tiny Tape Out 2, and it was Matt asked me. Met him at the Hackaday SuperCon, and he asked me later, "Oh, you can submit something if you like to Tiny Tape Out 2. It would be nice." And it was like 3 days left or something until the deadline. And I was at the time I was exploring FPGA, so I was a little bit familiar with Verilog, at least to that extent that would fit on Tiny Tape Out. And I sat down and made like one project that would show the capabilities that are possible in that run, because you are limited to like the IO clock is only like in kilohertz range. And I wanted to make a project that shows an actual practical use of that. And then once I was finished with that one, that was like my last video, I thought, oh, well, I can still submit like a meme project on top of that. And then I just encoded an animated GIF, the Rickroll, to fit on there and put it as a secret file. I had even a typo, I think, in datasheet document or something. Anyways, I wouldn't think that is actually the project that would go more or less viral. But I needed something to put out on YouTube quite quickly after it returned, and I thought, oh well, I can do it right now with the meme project. And yeah, of course, I have to go clickbaity. It's YouTube meta, but I can talk about this a little bit. So for me, at that time, it was the best chip in the world, especially because you have so many projects on there. And also we have finally like Rickroll etched into until eternity of time into silicon. There is no way back.
Yeah, you can't
The
erase this one,
resolution
huh?
is crappy. It's 32 by 32 and I think 4 frames or something. So
Yeah,
I had like to shrink it down and down to 450 bytes. And even the GIF header is already so big.
yeah.
It has like the fun thing is animated GIFs. Usually you would have like GIFs that are compressed, and for them to be animated, that was like a Netscape extension. So for the Netscape browser, so you
Nice.
have actually the word Netscape in the file encoded. So if you like,
Wait, really? Wait, still?
yes,
No
that
way.
is the marker. Yeah, that's the fun fact. Yeah, that's like in the header there is like one marker that says Netscape whatever
Hmm.
that indicates that's an animated GIF. Otherwise, it wouldn't like animate. It would show just the first frame.
Is this how? Was it Mark Andreessen? Is it Horowitz or Andreessen? One of them did Netscape stuff. I forget. That's how they made their money.
I don't know. I don't know
Yeah,
who did
yeah.
it, but I was trying like when I wasn't very familiar with GIF. I know the compression and so on, but I was trying like to shrink down the file back then, and there were extra headers with description and so on, and
Yeah.
I removed them manually because I there is not much software that you can use. You can use
Right,
online
exactly.
generation and so on, but I used GIF construction set. Some older folks might remember that was one way of generating animated GIFs back in the time. And yeah, I tried to remove the headers, and then it stopped working when I removed like this Netscape marker, and then
Really?
I researched a little bit and so okay, yeah, that's the indicator for an animated GIF.
Yeah.
So to unlock the capability.
It's like code muncing, like muncing is like when you like knock stuff off a board. Muncing? That's the word?
Yeah, yeah.
Yeah, yeah, yeah. It's like the code version of that. Yeah.
The last decoupling cap.
That's right. You had to put it back on. Yep, exactly. The Netscape cap. Yeah.
Yeah, I wouldn't. Probably the people that were developing Netscape couldn't imagine what they will unleash, like the
That's right.
meme world.
Oh man. So yeah, and that's interesting too. So you were in the FPGA space. So you turned this around super fast. Obviously, you talk about it in the video, and people should watch that video. We've talked about it a couple times, but to actually get that down, now you have 450 bytes. Those are individual registers that are sitting in the silicon. Can you just kind of like walk us through what those actually are in terms of the data, how it's in the silicon?
So just storing data, I would say it's a ROM.
Okay.
Basic ROM.
Yeah.
And what it takes is just a clock signal. And each clock, it would just expose the next byte of the ROM file on the parallel output, which is 8-bit. And what it has internally is just a counter that will loop after 512 bytes. So it's just padding zeros at the end. And Bitluni, I had to put a string there as well.
You got it. Yeah.
After the end of the file.
Work, right?
Yeah, and
Bitluni is the new Netscape. You have to add that to the silicon.
No, it's I mean, it was my first like silicon project. So I couldn't. Now you can put like art on the actual silicon so you can see it on the microscope. You can edit the files that are generated as output. It's easy, I think, in the runs that are currently, because you can put analog stuff on there as well now.
Right.
So
Well, and this is interesting too, because like Matt told us about like all the changes that came. I think it was from 3 to 4. That's where like now the analog stuff is enabled.
Yeah.
What I'm really wondering is, have you been putting new stuff? Like you have stuff in the pipeline that we haven't seen yet. So like that means that because all of the stuff we're talking about, like the Rickroll is in 2. And then 3, and now we haven't even. I think 5 is shipping soon. So, like, what are we going to see from Bitluni? Come on, like, what are we? Any previews?
I didn't submit. I thought I would submit something for 7, but I didn't make it in time. Basically, I'm too ambitious now for that. So one thing that I was trying to develop, I had like one stream where we wrote an assembler and interpreter that runs in the browser. That was also one video that I made. It was like crazy because you can do this like in 4 hours. I don't know if I used ChatGPT also for that, but developing own assembly language with interpreting. And so the purpose of that would be, I'm using several platforms like microcontroller platforms, and I want every time I try to develop something to show how the project runs, like a handheld game console or whatever, and I have to rewrite a Snakes game and whatever every single time. And I thought, okay, let the people write games for that, and I will make it to run it in the browser, and then it will run the same way on the interpreter on the microcontroller. So that was the thing. It generates bytecode at the end that I can put on the microcontroller and will run. I showed that, I think, in the video with one of my handhelds. And I thought, oh, okay, let's put that on silicon for this Looneyism. So it wasn't me. It wasn't me to call it like that. I just took the name afterwards. And
does that mean that if you had a clock in there, eventually it would be each clock cycle would be the Looney tick?
Yeah. Oh, that was good. Yeah, something like that. But I'm not sure if it like a whole process like that. There are processors and FPGAs on tiny tape out runs.
Yeah.
But I wanted to put a whole processor on there. And since Matt already showed that DACs are easily possible, there are templates for that.
Mm-hmm.
I would imagine to have like a project, at least I started on stream, to have something like a CPU with built-in GPU for Vectrex like things. So you have like a vector scope output.
Okay.
You can run it maybe on the oscilloscope or whatever with a CPU that runs that Looneyism assembler that you can write in the browser and simulate there or whatever. So that was the idea, but that's way too ambitious for like the time that I took for that. I think I thought, I will make it in 1 week, and then nothing.
If you don't sleep, right? Like 24 times 7. Right?
We struggled with, I say we because my community while streaming, there's only like 20 people or something are watching, or 30 people are watching on Twitch and YouTube. While streaming,
before we say streaming again too, how do people find this? Because we'll say it at the end, but people who are like, I want to be there for this, right? How do they get to this? It's just the
Bitluni Live is the channel name.
Okay.
Yeah, that's an extra channel. On Twitch, it's Bitluni. So now I'm parallel streaming on both. On Wednesdays at 8 o'clock in the evening, Central European time. You have to take your time zone.
Yeah, I think that'd be
basically
2 p.m. US Eastern, and then probably 11 a.m.
A little bit inconvenient, but at some point people sign off in Europe because they're tired and have to go to work. I picked Wednesdays because it wouldn't collide with other streams.
Yeah.
Anyways, the people are quite helpful with catching my errors and so on. And what Tiny Tapeout 7, it had more GPIOs. So you have input-output pins that you can use for like connecting SRAM, because RAM is very expensive. You can only store few bytes in Tiny Tapeout and then in D flip-flops, and then your space is gone. So just writing the memory interface was so challenging already to synchronize that correctly, because you have to break up the addresses like 16-bit addressing. It's like the memory management or the accessing over like 8-bit interface is a little bit more difficult. And then externally, you would need like some multiplexers or whatever to enable the addressing chips. So you need some buffer for the address, 16-bit address or 10-bit address or whatever, and then use the I/O lines to like manage the input outputs of. It's already a task on its own. If you're not familiar with that stuff, like I'm not really familiar, but to handle that correctly.
So you're using external flash, external SRAM, and then you're maintaining your own bus. Then, like you're basically making a bus master kind of thing.
Yeah, basically. Basically, that's what's necessary right now. I think if at some point, if there are even more like lines available, like to have more than 8 address lines, because that's not really enough to have like a lot of RAM or even flash. I mean, you could activate flash or switch it like that. Anyways, don't want to dive too deep in that topic, but it's already challenging. Yeah,
I think it's actually really good indicator. I always get frustrated when, I know this is a very different realm, but when subsequent part families, like a silicon company, be like, oh, we have this new microcontroller, it's so great, and then the flash and RAM stays the same, and like on board, right? And it's but like, in a similar way, like that is often like geographically on a piece of silicon, like it's just so expensive, to upcycle through to move up to, from 512 to a megabyte of flash or 256 to 512 of SRAM. Like it's just like a lot. It takes a lot of space, and that's expensive.
Oh, yeah, that's the reason why it's expensive is because it's all IPs basically of the foundries. I believe it's the foundries. I don't know the details about that, but what happens right now is if all the tiny tape out stuff is open source. So you can reuse it commercially for all your projects, or all the details, how it physically is shaped on the silicon. Everything of that is right now open source. And for the process that is 130 nanometers Skywater right now, there are ways of storing, like implementing SRAM or DRAM or whatever, that's way more compact, like way more efficient, which basically exploits, I don't know, the physics there. It works, but you wouldn't, you have to like try and error for a long time to develop that. But that stuff is not open source, and that's the issue right now. If you want to have like SRAM, then you have to use like
you have to use the transistors, and you have to hold the state in like a flip flop. Yeah, exactly.
Which are quite huge.
Right. Yeah, I mean, like, if you look at like the DRAM structures, they're often big like capacitive cups, right? And then there's the column and row controllers, but yeah, like that's like that would be a custom mask set. I'm sure that's like an IP block that you drop in that you're talking about. Same with flash. That's basically weird,
Yeah. And that's one of the issues, that it's all intellectual property that you can't use for a project like that. But
got it.
eFabless, I had in the Tiny Tape Out 7 run, or I think there was the possibility to use such IP blocks, because eFabless had like experimental run for that.
Yeah.
But it's like an exception right now. I don't know where the future goes, but it might happen that at some point there will be like a shared SRAM block or whatever for inside of Tiny Tape Out. So that's why I think it's quite difficult to put more RAM on there, more and more RAM, because you have like a block that you license from the foundry, and then you go with that. Never change the running system.
Like flash, RAM, all these things that are in there, right? I mean, it's all the same ingredients. It's like that scene in Silicon Valley where the main character's like, take scrambled eggs, right? What are the scrambled eggs made out of? Electrons, right? And it's just like, yeah, it's all made from the same stuff, but it's like it's a completely different thing, right? I mean, it's not like like the way it's assembled actually really, really matters in this case, and especially the testing and the just knowing that it works is pretty damn critical for making something that's not just brick.
Yeah, I can imagine. I mean, many of those companies that have run those experiments for such a long time, which were very expensive, they want just to protect their investment at some point. But it would be nice to have like really efficient RAM and flash that's open source at some point.
It would be. I wonder how many iterations it would take to get there, right? And it's like, but maybe if you had a couple maybe I'm overthinking it in terms of the things it would need to have. Maybe like if you had the structure, you could have basically a design of experiment where you have 1,000 different versions of the same structure with small tweaks across an array, and then you're like, oh, actually it's row 25, column 4. That's the best one, and we'll just use that from now on. That sort of thing.
So actually, something like that is what we see on Tiny Tape Out with other things that has happened, like with testing the internal clock speeds. So there were many experiments before the analog stuff was out there. There were already tests on the Tiny Tape Outs that were tested. Oh, how much can we run internally? What is the highest clock? And there were many experiments that were just exploring those details. So it's happening, and it's happening in parallel, because you have like 200, 500, whatever experiments on there, or on one chip. So that might also happen with the analog stuff. Once it's arrived, like when we have like documentation and the tools that make it really convenient to experiment stuff, there are some people that are really into it, testing that, and I think something will come out of that.
Yeah, it is interesting.
It might take years because the iterations are slow.
Yeah, exactly. Yeah. I mean, like and thinking there are test structures in silicon wafers, even internally, right? So, the engineers will run test structures to off the main area, to run different experiments or whatever. It's just now we're using the tiles that are on Tiny Tape Out, which are lower cost effectively. So and very long,
Yeah.
like you're saying. Yeah. It's better to have complete control of the fab, of course, if you can get it. It's nice work if you can get it, right?
Yeah.
I am curious about your. So you mentioned a couple times the FPGAs and specifically the Go-in FPGAs. I've seen those before, but I've never used one. It's been a long time since I've used any FPGA. What are you doing on FPGAs these days, and where do you suggest that people start around the Go-in one specifically?
So when I started that, I was reached out to by Gabriel, who founded like Lushy Labs. That's like a website that basically has not experiments but tutorials for FPGA development, and that was based off the Go-in FPGAs, the 9K ones. Now you can get 25K, which are really like as big as an Arduino Nano or something.
Yeah.
So basically a stick. And what's interesting on there is that you have like an HDMI connector on that. And it's powerful enough to, like the 9K is already powerful enough to generate, or fast enough to generate like a 720p signal, which is basically perfect for HDMI, and you can do smaller things with that. Unfortunately, that uses IP blocks from Go-in. You can use like the IDE that's free to use, and use the IP blocks from Go-in for that, as well as like the built-in memory. They have like DRAM stuff on there, or PSRAM on the 9Ks, and I think the 20K has like the also external DRAM or something. And then you have USYS, which is basically the open source variant for generating the bit streams. That doesn't support that for now, I think, but the support grows as we speak. I don't know the details. I didn't look into the latest updates, but basically what you need for HDMI is differential signal generation, and I think that's like an interface that's very specific for the FPGAs. And it lacks there, but what happens, like on Lushy Labs, you have like a Visual Studio Code plugin that you can basically install the free open source tools, uses and stuff. That's like one package, one executable that you can install on your PC, and then you can basically start writing in Visual Studio Code, and you have like an emulation test bench. It's called a test bench, basically, where you can just flip the bits of the input signal, like in a sequence with clocked or whatever, and then it will simulate the outcome even before you upload the bit stream to the FPGA. So that's quite convenient, and I think Lushy Labs has even tutorials how to develop a CPU on the FPGA. So it starts like with a blinking LED. The typical stuff that we had once with microcontrollers, it's basically now available for the FPGA stuff, especially for the 9K in this case. And it's like from China, you get it for $20, which is really like, yeah. You can't even get a Raspberry Pi 1, I think, for 20
I know,
bucks.
right? Exactly. It's like the Tang Nano 9K. Like you said, has an FPGA thing on. What is the other connector? It looks like there's a ribbon connector on there. Is that just for?
Yes. You can connect basically a screen, a TFT screen to that.
Okay.
I think the first one was Tang Nano 1K. Then we had like 4K, which had also a camera interface.
Oh, cool.
I bought all of them to just test what they're capable of, and there are so many variants of the Go-in that have like core like inside. 9K doesn't have like a RISC core additionally to that, but you can make like a RISC-V core, put on soft core on there. So there are many variants, but the Tang Nano 9K has like this parallel interface where you can just connect a parallel like TFT screen. That's what I was using to, like on stream, I made like an oscilloscope, or started developing an oscilloscope that worked like with an external ADC that was sampling at 50 megahertz or some mega samples, dual channel. And yeah, that the capabilities of the 9K are barely fast enough like to get input from that ADC in 50 or 100 mega samples and then display it on the TFT.
Nice.
So you
Yeah,
can.
but that's great too because you're like on the edge of where the capabilities are, and those constraints are also kind of like that's like forced learning at that point, right? It's
Yeah.
you got to get around to
So
somehow.
actually, the bottleneck at the end is the PS RAM on the on actually on the 9K. I think the 20K is better because it has like DRAM, which is faster, and the PS RAM is somewhat serial internally. It's on the same chip, I think, but it's very complicated, and then figuring it out yourself is difficult. But the Go-in IDE, Moon River Studio is, I think, the name.
Oh, really?
That has like IP blocks. Yeah.
Moon River, like MOUN.
Yeah.
Oh, that's the same as the.
Yeah, I think Dave was talking. No,
because that's what WCH uses as well for the.
No, sorry, okay. I mixed up. Sorry.
Okay, it could have been though, right? I mean, like
Moon River. It was another. I think.
Okay, so it's a different, like maybe IDE that looks like just the generic.
Oh wait, no, it's just Go-in.
Okay, all right, no worries.
Wait, Go-in FPGA designer. Yeah.
Are you using their tools?
Just mixing up. Yeah,
are you using the other stuff?
I had to use for like the things that are basically on the edge of the capabilities of the device. I have to use their stuff because the IP blocks are like developed. So they have like the if you need like a frame buffer, so basically the memory to store a whole frame to display it on HDMI or on TFT, which you need to render like anything. If you can run it like in parallel on the fly, you can basically
seeing the scan lines and stuff like that. Which has its own like aesthetic, right? You know.
It's cool. Yeah, I think I managed to do like a Mandelbrot on the fly with few iterations or something.
Okay. Yeah.
But usually you would need like something to run in the background and put everything into this frame buffer, and then the frame buffer is scanned with like the HDMI or whatever. And developing this frame buffer is already quite challenging because you have different clock domains. You have like the clock domain of HDMI, which is way faster, and this is where it gets really complicated if you do FPGA stuff. So the simple things is, I think tiny tape out is simpler than trying to exploit every capability or explore every capability of an FPGA.
Yes.
Because you usually would work like with one clock. Maybe you have an experiment internal clock, and then you have 2D flip-flops where you synchronize stuff. Yep. But it's a science on its own, which I am not really familiar with. And
it's not worth it as like in terms of just pure dopamine over time, right? Like you're just trying to get people to build their first thing, right? And if you're like, well, if you start to, I remember the first time I started doing FPGA stuff, I had seen FPGAs as this amazing answer, and I was trying to like replace the 6502 on like a legacy product, and I was going to be like, oh, I'm going to just re-implement it in the maybe it was a 6509. I don't remember what it was. The 6509.
Just re-implement it.
Just re-implement it. Yeah, no big deal. Look at this. I found a core on opencores.org. It's like, no. And then it was like a 50 megahertz domain and a 33 megahertz domain, and I had to do all the clock and stuff. And it's just like, what are we doing here? It was like, like the Dunning-Kruger, like you mentioned at the beginning. I was like, new engineer. I'm like, how hard could it possibly be? And I effed around and found out, you know what I mean?
There's where physics kick in.
Exactly. And just on the realities of project timelines. Like, could I have done it? Maybe, I never found out, but I sure as hell did not do it.
At some point, you have to have a high frustration tolerance. And there's like you have IP blocks for that. Totally. Usually in the Go-in IDE, I think there's even like an IP block for frame buffer, so you can just use it.
Sure.
And don't worry about that, and develop your project and propile that.
And then when in terms of like those IP blocks on a Go-in type, like using the Go-in FPGA tool, like you're talking about, that has to stay captive. It's like an encrypted bit stream type of thing. Like so you pull your logic into that instead of being able to pull the block out to the open source tools. So like
it is like you have a binary file.
Okay.
So that's like in the project file you see there is a binary file with the bit stream, whatever. Mm-hmm. And I don't know what the licensing is about that. So if you want to use it for commercial stuff, you probably have to license it somehow. But that that's never a question for me because I don't want to.
So for the frame buffer, that's a good example. If you wanted to choose to use the frame buffer, you're like, I'm just going to use this as a tool. I'm going to use it, whatever.
Yeah.
Does that mean then that you have to operate with inside that tool, or can you actually use the binary and pull it out to the open source tools and just render
That's
it?
a good question. I don't know actually.
Okay.
I can't answer that.
But from a practical perspective, when you do need that IP, you just say, I'm just going to use their tool, that kind of thing.
Yes.
Okay.
It will basically generate everything. I think you can even name that or whatever. You get like a Verilog interface, like a header, and then the bitstream in one file, and you can just access the stuff.
Good old blobs.
Yeah. Unfortunate. I was looking at a bitstream. Maybe you can decode it somehow. And at some point, it needs to be converted to the actual bitstream or whatever ends up on the flash. So maybe you can export it from the flash. Maybe you know the thoughts.
With a million monkeys and a million oscilloscopes, we could decode this. We could decode this and reverse engineer it. But why not just build your own at that point?
I think that might be happening like on the open source tool. So people just extract the bitstream from the flash or whatever, or from the file, and then see, oh, okay, that has to be how that works or whatever. I'm not sure, but
okay. Yeah, I mean, it is still magical to me that it's literally just like bits loading around the edge of an FPGA, and it's like that bit stream determines the magic inside. It's just magic sand, magic sand at its purest,
Yeah, it's always scary. I don't know, when I started with the electronics and FPGA, it was basically anyone who enters the realm never returns. It's like a rabbit hole.
Yeah,
it's like it
truly,
opens a
truly
new universe.
Yeah.
You just open up like the dimensional portal and you disappear. Any FPGA decoder just disappears in that realm and never comes back.
That's right. Yeah. Sorry, man. You're getting sucked into the vortex. Speaking of, this is usually part of the show where we talk about future stuff that you're excited about, things you're working on, obviously people can go to your stream and look at it. But what do you, where do you feel the draw of technology these days? Where is it pulling you?
Oh, wow. That is a good question. Oh, I would love to move more back to art. Like,
oh, really? Oh, okay.
Yeah. I like that. Like,
do you have a background? So you said you have a software background. Do you have an art background as well?
At some point in my life, when I was, I think, 10th grade in school, I was choosing my path because I was good in math and I was good in arts. And then I chose to go to, I was coding in my free time quite early on. And then I had to choose between two schools. Like, one was about arts and one was about programming. And I chose the programming path. But arts never left me. So at some point, like in, I think, 2000 or whatever, in work, I met a friend with whom I founded like a demo scene group, and we coded a few intros, demo scene intros, like 4K intros. That's also exploring the limits.
Can you explain demo scene real quick?
Demo scene is computer art. Basically, the demo scene was basically it's demonstrating the capabilities of a computer in visual and acoustic way in some sort that developed from the cracker scene back in a time where you had like software that was cracked by some hacker, and they liked to put like a small file with the crack that basically showed off like graphics and music and a scroller, pop-up bars, like moving stuff on the screen. And that people liked, like the coders like to show off the capabilities of coding and exploiting also hardware, like the actual stuff, like copper bars are basically exploiting hardware registers of to drive the CRT and stuff like that. It was fancy back then. And then from that, basically the demo scene developed where people like to show like animations that were calculated on the fly or pre-calculated later when there was more memory available. And that demo scene parties are basically like competitions where you have like different categories, C64, Amiga, PC, and then different sizes. So you have like PC demos are basically unlimited, I don't know maybe there is a file size limit, but you can put like MP3s, which they have always like super cool music and state of the art graphics. In some way of fashion, they like try to like excite you. That's the background. And there are some categories that are smaller, like 64K was like 64 kilobytes intro, which usually used like generated graphics. So it was pre-calculated or calculated. On PC, it is sometimes like textures and so on. If you do 3D stuff, it's pre-calculated because you have enough RAM. On C64, it's not so much RAM.
Yeah.
Then there is like the 4K category. So 4 kilobyte intro, you can imagine 4 kilobytes of data fits like on one, like in ASCII, it fits on one page, like A4 page or letter. It fits, and that's all the code for generating the music and animations that runs for maybe 4, 5, up to 10 minutes or whatever. And so
it's like a pure optimization exercise, basically, right? What's the most you can do with this super constrained space?
Yeah, and that I was into that. I got in touch with, like, I saw some demos in the 90s. I don't know where I got them from. I think they were on like a CD-ROM or something that I bought. They were just randomly put on there that had nothing to do with whatever content was on the CD. And then I bought a book, PC Underground was the name, which basically explored like the techniques of writing 3D engines and stuff like that, rendering graphics or playing mod music, which mod files are basically you have the instruments put there and the MIDI notes or whatever notes and the effects, and that renders the music. That's I think from Amiga back in the time, but C64 works the same way with not samples, but with like the
one sample would take up 4K without much thinking about it, right?
Yeah. So basically, usually a 4K intro has like synthesizer and some form of punchy graphics. So like raycasters. So a typical way nowadays that developed with the faster CPUs is where basically you have something like in Blender, but it's rendered in real time, and usually some artsy graphics there. And I was always interested in those things, especially trying to put like in the really small size like of 4K, because my attention span isn't that long to code like 1 year. Some demo scene groups like code for 1 year on a demo to fill all that content, and my attention span wouldn't allow that. So I concentrated on the 4K competitions and basically tried to put the best tech in there. That's like tech demo code. So many terms here from the demo scene. Yeah, and then I basically participated with my friend who was more proficient in music than me, like in the beginnings of 2000, around that time. Yeah. So that was the art part that I was doing. And
when
now,
I heard, Matt said that on Tiny Tapeout 8 there will also be a demo scene in there somehow. Like, is that right?
Oh, really? I don't know. I must admit I didn't follow all the projects. I mean, there's so many contributions, but there are like, of course, there are some old school folks there. They're putting like Z80 chips on there,
yeah,
and stuff like that. So and also someone put like a Raycaster GPU on one of the Tiny Tapeouts, which is really cool. So you can render something like Doom or like Wolfenstein or
oh man, yeah, that's really cool. And I feel like I would have to go to one of these events to actually understand, to actually feel what it's like. How does one find those sort of things? Is it like underground, like you need an invite, got to know somebody? Should I call you up?
No, that's quite open, but it's more popular in Europe. Usually there are a few events, and then usually you can find them. Demo scene parties, they're all around the world. I don't know if there are some like in Australia or there are a few, I think, in US, but I'm not really familiar. I just lost track at some point when I started like doing the YouTube thing and other interests. I stopped to competing there.
I make my own demo scene party. It's on a stream every Wednesday.
yeah. Basically, I mean, there's the stuff that I'm there. I could contribute like with some stuff that I made here, because there's like the wide demo competitions where people sometimes do hardware stuff. So basically merging like programming capabilities or this multimedia stuff with some hardware stuff is also a thing. It's not very common, but usually people reward that. So there is some intersection with, let's say, the hardware or the electronics maker community with demo scene and interests like that, and probably Star Trek.
Yeah, probably. Yeah, we're all in the same buckets. They're all adjacent buckets, at least.
That's true. Yeah.
Where can people find your stuff online and make sure they're following you so they see your next demo scene, your next chipset, your next project? How should people find?
So demo scene, I'm not sure on which party I would go. I try to stay within Germany, but yeah, on YouTube, basically on YouTube at Bitluni is basically, if you look for Bitluni, you always find me.
Bitluni, right?
Yeah, I don't really maintain my website, so if anything, then there will be a link underneath a video description that points on a GitHub. That's also like, basically I picked the name from, like, my demo scene handle was Lunatic or Loony, and then I picked Bitluni because it's unique. Otherwise, people wouldn't find me, and that's why you can find everything like GitHub. And usually the YouTube videos, they conclude every long project that I'm doing or show a part of it and then point to the right directions and code-wise and so on.
Awesome. Well, thanks so much for being here today. Love hearing about this stuff. I can't wait to see all the other stuff you build. I mean, just keep making fun stuff, and it's a joy to watch you work and have fun with it. That's great.
Thank you.